Okay, my name is AMIR. I'm a software developer. Uh, because I do a bunch of front end and back end development, and I'd say my number one struggle, or I'd say pain point, is trying to introduce changes into architecture. Because then you got to tell the ops team, and you got to update a lot of different things, and a lot of people have to be involved, and sometimes it's more effort and work than it's worth. So I'm going to cover a bunch of topics, but basically my premise and my thesis is that all you need is Git and Docker. No matter what you're doing, that should be all you need. And in fact, I'm going to twist this at the end and actually remove the Git part entirely, but more as a little tiny crazy way of doing things. So I have a few slides, but most of it's going to be code. I guess to start, who here has used Git? I'm assuming everyone, right? Okay, easy. Have you guys used Docker? Yeah? Okay. So I think most people, when they think of Docker, they think of containerizing their app and deploying it. But I'm going to show you how to use Docker to actually build your entire app. So what I've done is I've decided to use a front-end framework and a back-end framework that are completely different. So on the front end, I'm going to use Angular. So Angular 2 or 4, whatever it's called now. And on the back end, I'm going to use Spring Boot, which uses Java. So to do this all, so let me go through some slides here. Obviously Git, everyone knows Git. The purpose of it obviously is to fetch your code and then do some automated tasks. So for example, if you have pull requests and you want to build it, make sure everything's okay, you can do that. And Docker. So if you've never used Docker before, it's pretty simple and pretty powerful at the same time. So essentially you create a file, a Docker file, and I'm going to go through one today, and you can basically create a recipe for a small container that hosts your entire application. And that container actually is almost a micro VM with its own OS. So it uses the host's OS kernel as well, so there is some sharing, but it's very powerful, and at a very low level, I'm going to show you how Docker can be used for more than just hosting your application. So I'll get to the code part. I think it's more useful. So again, generate application from the first step can be used for the second step to actually deploy. Let's start with actually the app. So it's a pretty simple app. It's a very simple app. It's so I'm actually going to show the app in a development environment first, not in an actual production environment. So again, it's a Angular front-end app with a Spring Boot back-end app. It has one RESTful API. You pass it your name, and the server returns back hello with your name. Pretty simple. So I'm going to start up the Angular app. I'm going to start up the Java app, and I'll demo that quickly. So the way the app is structured, in the final product, we want the compiled client code to end up in a resources in a static folder, because Spring Boot will host static files for us. So that's what we want in the final version. So let me show you what it looks like right now. So if you've never used Angular before or other more modern JavaScript frameworks, this is using Webpack. So Webpack is bundling up all my resources on the client, and it's serving up my Angular app. So if I type in my name here, I hit submit. So you see down here, it's calling my backend, and the backend is returning hello AMIR. Okay, so pretty simple. But obviously you don't want to have to do a lot of work to get this all bundled up into a deployable app. So let me stop both processes here. And let me show you what we do with Docker here. So it's still a bit small, eh? Let's go crazy. 22. Okay. So this is the first time I've ever seen a Docker file. It might be a bit overwhelming, but I promise it's not that bad. So the great thing about Docker is the ecosystem. So if you look at this very first line here, and I'll try to go line by line just so we don't skip too many things. This from part here, crucial. So what this means is, it means I want to inherit from someone else's container that has already been created for me. So node colon 8.4.0-slim, what does that mean? Well, if you go to a public registry called Docker Hub, it is where all the publicly available images are. So if you were to type in, what was it again? Node? So you see here is a node official. So what that means is there's actually a container out there developed by, I'm assuming, an official party, so most likely the people who actually develop Node, where I can actually go and get a version of that and use it for whatever I want. So for my Angular app, I want 8.4-0. I picked Slim, but really Slim is only for when you want to deploy. You want to keep your container as small as possible, but I'm using it here as well. So what I'm doing is I'm saying give me the container for Node, and I'm going to do something with it. So what I do is everywhere you see run, that's me running a command in the container. So the only reason why this is a little more complicated is because I've named this client builder. So I'll get to that later on. So for now, we have a container. It's going to run a Node app for me. I'm going to copy specific code into that container. So all the code in source main front end, and if I open up source main front end, you'll see here I have my my Angular app. So source main front end here, all my actual Angular code is there. So if you look here in package.json, I don't know if anyone's familiar with npm, etc., but there's a bunch of scripts here. So npm start was what I used to develop the app. npm build is what I'm going to use to actually build it. So I have an actual generated client app that's not going to be for development. This will do minification, obfuscation, code splitting, etc. So if I go back to my Docker file. So it's copying the source main front end entire folder into dot. So I specified the workdir in my container as /app. So from now on, all commands will happen within the /app folder. So now I have all my raw client code within this container. Then I'm going to tell it to run yarn. So yarn is an alternative to npm install. Highly recommend it. It's much, much better. So this is going to fetch me all the dependencies that are defined within my package.json. If there was a post install script, it would run those. So now I have all my dependencies. So basically everything you see here in node modules will get copied over. I think in Docker ignore. So I did skip one thing. So right now I mentioned Dockerfile. Dockerfile is also paired with another file called Docker ignore, very similar to Git ignore, where you can specify which folders not to copy over when you do copy commands. So node modules is OS specific, so you never really want to copy over your node modules folder. So that's why in the Docker file, I'm telling it to do yarn. So it's going to basically generate its own node modules folder with all the requirements. And then it does the npm run build, which will build the client app, and the client app, once it's been compiled, is in an output folder called dist. So in here, outdir is dist. So if I were to come into here, if I were to go into terminal, let's see, if I do cd source main front end, npm run build, so this will actually do the build, and might take a couple of seconds, but we'll see a new folder here called dist. And this is happening on my local machine, not inside of a container. So it's done. So if I were to go into here, there's dist folder. So the output's pretty simple to understand. Index file with some JavaScript code. Pretty straightforward. So in this Docker file, what's happening here is I'm telling it, run this as a first step. And I've named this first step client builder. I don't really care about this container. After the build has been done, the container to me is kind of useless. All I really care about is what the build did. So what's the output from build? So in the second step, I'm going to actually build my Java app. And to do that properly, I need to take the client code from the first step, put it into the right spot in this container, this Java container, so that I can build my Spring Boot app. So Java uses jars. In this case, we're using a jar. The jar will be a compressed file with all my code compiled into it. This includes the static client code. So if you notice here, again, I'm doing from OpenJDK version 8. I'm using the actual JDK because I actually have to compile my Java app. Again, workdir. This time I'm copying over all the code because it was just easier that way. I could have probably broken up the client code and the backend code to be separate front-end directories. Might have made things a bit easier. This front-end code is not useful for this copy command. It's going to be ignored. But what isn't ignored is the fact that this is the magic line right here, quote-unquote magic. And this is, by the way, this is fairly new. I don't know how long. I think 1.12. So I think only the past 5 months Docker's had multi-stage builds. So before that, this didn't exist. So this line here says, hey, the folder in app/dist from client builder, I want that. So I'm copying from my first container into this new container because I want the outputted client code inside of the static folder within my Java app. Once I have all that code, I'm going to use Gradle to actually build my application. So Gradle, similar to NPM, it will use this build.gradle file here. So in here, here's all my dependencies, Spring Boot, pretty simple. And then when you launch build, it'll generate everything you need to run your app. I could stop there. I could use this as my final container because I have a jar now. I could run it. But when it comes to creating containers, something you always want to keep in mind is you want to keep the container as lightweight and as minimal as possible. So the size of the container and the number of dependencies in that container, you want to isolate that to as small of a size as possible. And the reason for that is usually when you containerize, you're thinking about scaling and performance. So you may want to scale this one container horizontally, who knows how many times. So the smaller the container is, the more you can scale with fewer resources. So I'll show you in a bit, but if I were to use this container right here, it's about 500 megabytes, the size of the container. So we're talking fairly large. So what I've done instead is I don't need the JDK to run a Java app. All I need is JRE. So I'm going to use a JRE Alpine. Alpine's pretty popular. It's a very lightweight, minimal version of Linux. It has doesn't have bash, so you have to use shell for everything. It can be a bit of a pain, but it is much more lightweight. So what I'm doing now is I decided to name my server builder, and I'm doing the exact same thing as before, except this time I'm only copying from the previous container. So if you notice here, I just created an environment variable app001.jar. This should really be passed into Dockerfile. This would not be something that you would hard code in here, but just for the sake of the demo. The reason I say that is that this is actually correlated tightly to whatever you have in build.gradle. So in here I have version, so this should be a variable you pass in, but keep things simple for now. So in here, I'm copying from this container. The output in Gradle is a build file, a build folder, sorry. So it's in build libs, and it's the artifact ID, so app-0.0.1.jar. And I want to put that inside of my app directory. And then I'm going to expose the port that I know it runs on. And I'm going to say, I have to do this for Alpine. It's kind of silly. But really, all I want to do is run the app. And that's it. So that's basically the entire process. I've built a pretty complicated front-end app. I mean, albeit this is a simple app, but I'm using an Angular CLI to generate all the dependencies. I'm using Gradle to build the server code, and then I'm running it all. So even if you don't want to use Docker to deploy, you could still use Docker to build your entire app, take the jar out of the container, and then you can launch it however you want. Now, why would you want to use Docker to build, you may ask, which I'll show. So first of all, let me actually show what it would be like to run the app locally. I've already done a build, so I'm not going to build again. In here, I have a compose file. So if you've never used Docker before, this might be a bit strange, but the compose file just gives us some commands. So what I'm going to do is actually, if you want to build the container, you do docker build dot, which will build you an image but won't run it. Compose will do things for you. It'll build it and it'll run it. So if you notice right now here, I have my Spring Boot app. I just changed this to pre on port 9000 versus 8080. So now if I come into here and I go to localhost 9000, it'll be the same as before. Only difference is I'm running this entirely within Docker now. There's no more npm running my client app and Gradle running my server app. It's all running through Docker. And the reason you want to do stuff like this is, and there's a lot of these companies, I'm not trying to endorse CodeFresh specifically, but this is one example of why you may want to do this. So I have here, and this is free, up to, I think, 10 builds a day or something pretty crazy. I have a system here with a pipeline where I have it pointing to my GitHub repo. So if I were to actually push code changes or a pull request, this will do an actual build for me. And with CodeFresh, it will actually deploy my app for up to, I think, 30 minutes or an hour for free. So I can actually test my app on here. So I don't know how much time I have, but I was going to modify the code a little bit and trigger a push to happen, and then we can see that. But I don't know, do I have time? Yeah? Is there something you guys want me to go more in depth, whether it's the Angular stuff, the Spring Boot stuff, or Docker, or just update it a little bit?